You're welcome to today's edition of our mathematics class. And as you know, this class will be for students who are preparing for their senior WAEC, GC, NECO, and probably JAM. Having studied the trends and patterns of these examination bodies, I have drawn up a list of topics that you are most likely to come across in your examinations. One of those topics which we are going to be looking at today is indices and logarithms. Indices and logarithms. I'm going to be treating these two topics together because there is a correlation between these two topics. This logarithm we're talking about is not a logarithm where you have to use your four-figure table. This particular logarithm, you're not going to be using your four-figure table. You're only going to be working based on the knowledge of indices. Now, when we talk about indices, we are talking about powers. You have to be able to express numbers in their powers. When we're talking about indices, it's just the plural of the word index. Now, indices, like I said, is all about expressing numbers in powers. Let's start with indices first. Okay, while you were in SS2, SS3, you have been taught the rules of indices. But today, I'm not going to be teaching you about the rules of indices. You don't need them. You don't have to state them in your exams. But your understanding of those rules will help you to solve the questions. Now, let's assume we have something like this. 2 raised to the power 2 times 2 raised to the power 4. This is an index number, and this is an index number. So that's why we call it indices. This 2 is what we call the base. This 2 is also a base. This 4 is a power. And this 2 is also a power. One of the rules of indices says that when the bases are the same and the powers are different, so meaning that 2 is a base here, 2 is a base here, the bases are the same, but the powers are different. It says that because the bases are the same, you pick one base. Because the bases are similar, you pick one base. And then the powers you add. Why do we have to add? We are adding because of the multiplication sign we have here. Meaning that the 2 is a base here, 2 is a base here. We are picking one base because they are similar. Then we add the powers, 2 plus 4. Thus, we are having base 2, 2 plus 4, we have 6. So, 2 raised to the power 2 times 2 raised to the power 4 equals to 2 raised to the power 6. If you want to do this manually, 2 raised to the power 2 is 4, times 2 raised to the power 4 is 2 times 2 times 2 times 2, which is 16. 4 times 16 will give us 64. So the same thing, 2 raised to the power 6, which is 2 times 2 times 2 times 2 times 2 times 2, which is also 64. The only difference is that you express your answers in powers. If you are given this kind of question in your exam, you might see it as very simple. But if you don't express your answer in powers, you are not getting the full mark. That is the only problem we have with the examiners. If you write 64 here, for those of you who use calculators, you won't get the exact mark you are supposed to get. If the examiner is lenient enough, it might just give you a half of the score. But writing it this way is why it is called indices. I hope that is taken already. So you should be able to express those numbers in powers. This is example 1. Let's say we have another one. Now, let's have something like 2 raised to the power 3, 2 times 2 raised to the power 2 times 3 raised to the power 2. Let's say we have something like this. Don't forget, I said the multiplication rule says that when you have numbers which are similar, whose bases are similar, that you should pick one base and then you add the powers. But look at this one. It's still multiplication, but we have different bases. This is 2, this is 3, but the powers are the same. The rule changes here, and it becomes 2 times 3. Because the powers are the same, you pick one power. 2 times 3. The bases are not the same. Good. 2 times 3 in a bracket, and then because the powers are the same, you pick one power. This then gives us 6 raised to power 2. This is the way your answer should look like. In indices, you should always express your final answer in powers. Express your final answer in powers. Now, let's say we have another one again. What this multiplication rule simply says is that when we have multiplication between two numbers or more, we are supposed to add the powers. Let's now say we have 2 raised to power 3 times 2 raised to power 2. This is another question. Sorry. Divided by 2 raised to power 2. In this case now we have the same basis. We pick 1. We pick 1. And then let's go to the powers. 3 minus 2. We are using we are subtracting the powers because of this division sign. So the bases are the same. 2, 3 minus 2. So our answer is 2 raised to power 1. Let's have another one. 2 raised to power 3 divided by 3 raised to power 3. 2 raised to power 3 divided by 3 raised to power 3. This is another example similar to what we have here. But the only thing that we change is the sign. Now, the bases are different, but there is a division sign between them, but the powers are the same. Now, this one becomes 2 all over 3 in brackets. The powers are the same. Then you pick one power. The bases are different, yes. 2 all over 3. But the powers are the same. You pick one power. Just like we did here, the bases are different. 2 times 3, but the powers are the same. This is what your final answer should look like. Like I said, don't forget, when you are expressing your answers, it should be in powers. Don't just leave your answer as a natural number. No, you should express them in powers. Now, there's another thing again I would like us to know in indices. We have been taught all those rules. Anything raised to power 0 is called 1. Anything raised to power 0 is equal to 1. Anything raised to power 0 is equal to 1. 100 raised to power 0 is equal to 1. 1 million raised to power 0 is equal to 1. A raised to power 0 is equal to 1. Let's just have that at the back of our mind. Now, let's say we have something like this. Let's have a question that is a bit complex compared to what we have done. Let's say we have something like this. Let's say we have a question like this. Like I said, don't forget to express to your numbers in powers. Let's say we have another example like this. 1 times 2 raised to power 4. We have something like this. 1 times 2 raised to power 4. How do we solve this? Normally, we know anything times 1 will give us that particular number. Normally, we say 2 raised to power 4. We know. But how do we express this in indices? 1, like I said, anything raised to power 0 is 1. So because this other number is a number, the base is 2. So we have to express this 1 also to base 2. This is 1, can be written as 2 raised to power 0 times 2 raised to power 4. The bases are the same. We write out 2, one of the bases, because they are the same. Then let's add the powers, 0 plus 4, which gives us 2 raised to power 4. That is it. What I'm trying to show us here is that we should try to express numbers in powers. Learn to express numbers in powers. Learn to express numbers in powers. Let's say we have another question here. Like I said earlier, I have studied the trend and patterns of these examination bodies. And there is no single year where we don't have indices and logarithm, both in objectives and the theory. You will have them. We have something here. 2 raised to power 1 minus y. 2 raised to power 1 minus y times 2 raised to power y minus 1 all over 2 raised to power y plus 2. everything equals to 8 raised to power 2 minus 3y. Now, this is why most of us in school will say our teachers give us white rice in class, but during the exams we will be seeing jollof rice or fried rice. Now, this is not difficult if you have an understanding of what we have just done earlier. Now, 2 raised to power 1 minus y times 2 raised to power y minus 1 all over 2 raised to power y plus 2 equals to 8 raised to power 2 minus 3y. This 1 minus y minus 1, 2 minus 3y, y plus 2, they are all the powers of these numbers. Now, the first thing we do is this solution. All of these are in, the powers are already 2. Let's try to express this. The bases are already 2. Let's try to express this 2 in base 2. Now we have 2 raised to power 1 minus y times 2 raised to power y minus 1 divided by 2 raised to power y plus 2. I told you when you are dividing, you minus, subtract the powers. Then 2 raised to power minus y plus 2. The bases are the same. Divided by, that's why we are saying minus y plus 2. We subtract the powers when we have similar bases. Now these bases are the same. 2, 2, 2. 2 times 2, 2 raised to the power 1 minus y times 2 raised to the power y minus 1 all over 2 raised to the power y plus 2. 2 raised to the power 1 minus y times this times 2 raised to the power minus brackets open y plus 2. We have to open a bracket here, put this in bracket because y plus 2 is just like a single power. But y has a value. We are going to look for the value of that y. So minus this singular power. We are subtracting the power because of this division sign. I hope you know this line means division. Equals to 8. Can be written as 2 times 2 times 2. 2 times 2, 4 times 2, 8. So 8 can be written as 2 raised to the power 3. Let's now put the original power there. 8 is written as 2 raised to the power 3. This is the original power. 2 minus 3y. Now, how do we solve this? These powers are the same. Now, let's figure it out. 2, 1 minus y plus y minus 1. Now, let's break this down. Minus times y will give us what? Minus y. Minus times plus 2 will give us minus 2. Minus times y will give us minus y. Minus times plus 2 will give us minus 2. Because minus times plus will give us minus. Then we have our 2. Equals to these 2. 3 times. In mathematics, you use the number that is closest to the bracket to multiply everything in the bracket. That number that is closest to the bracket, whether it is a number, a sign, or a letter, use it to multiply what is in the bracket. So 3 times 2 gives us 6. Don't break it down here. They are the powers. 3 times 2 gives us 6. 3 times minus 3 will give us minus. 3 times minus 3y will give us minus 9y. Give us minus 9y. Minus 9y. Now, this is what we do. We cancel the powers. The bases, they're the same thing. When you have something like this, one base equals to the other base with their different powers, you cancel the bases. Now we are left with 1 minus y. Now we are left 1 minus y plus y minus 1 minus y minus 2 equals to 6 minus 9y. Now let's start something from here. 1 minus y plus y gives us 0. 1 minus 1 gives us 0. We are left with minus y minus 2. Again, minus y plus y gives us 0. Just like when we say minus 1 plus 1. I am owing you 1 naira, and I have 1. I am owing you 1 naira, and I have 1 naira. So when I give out that my 1 naira, I have nothing left. So minus y plus y is 0. 1 minus 1 is 0. So we are left with only minus y minus 2 equals to 6 minus 9y. Now let's collect like terms here. Minus 9y comes here. Whenever a number is moving across the equality sign, I always call it the red C. It's moving across this red C to the other side, it will change its sign from here. If the number is positive and then moving across the red C, it becomes negative on the other side of the red C. If it is negative and moving across the red C, it becomes positive on the other side of the red C. So minus 9y will be moving across the red C. It becomes minus y plus 9y equals to 6. This minus 2 so also has to move because we are collecting like terms. 6 plus 2. Therefore, we'll be having minus y plus 9y. Just like saying minus y plus 9y. Just like saying minus 1 plus 9. I am owing you 1 naira. When you see minus, take it as something you are owing someone. And then when you see plus, take it as what you have. That's the logic you should also always use. It's easy. So I am owing you 1 naira, but I have 9 naira. If I give out my 9 naira, that means you give me back 8 naira. 8 naira belongs to me. So I'll be having plus 8. So minus y plus 9y gives us 8y equals to 8. When you divide both sides by 8, our y equals to 1. So the value of y in this question is 1. The value of y in this question is 1. Minus y plus 9y gives us 8y equals to 6 plus 2, 8. Divide both sides by 8. Divide both sides by the coefficient of y. Now, how do we check if our answer is actually correct or not? Just for the purpose of being sure. Now, 2 raised to the power 1 minus y. Our y is 1 already. So 1 minus 1 times 2 raised to the power y. Our y is 1. 1 minus 1 divided by 2 raised to the power y plus 2. Our y is 1. 1 plus 2. They say it's equal to 8 raised to the power 2 minus 3y. Our y is 1. Now we have it this way. 2 raised to the power 0 times 2 raised to the power 0 all over 2 raised to the power 3. They say it is equal to 8 raised to the power 2 minus 3 times 1, because our y now is 1, will give us minus 3. We are trying to check if our left-hand side of the equation is equal to the right-hand side of the equation. 2 raised to the power 0 gives us 1 times 1 raised to the power 2 raised to the power 0 gives us 1 all over 2 raised to the power 3. Let's see if it is equal to 8. 2 minus 3 will give us minus 1. So 1 over 8 is equal to 8 raised to the power minus 1. In indices, whenever the power is negative, now that takes us to one of the rules again. 1 over 8 is the same thing as 8 raised to the power minus 1. Whenever the power of a number is negative, for example, we have a raised to the power minus 2. We can write it this way. This minus becomes 1 over. Again, when the power of a number is negative, that negative sign becomes 1 over. Then the base and then the power. So another way of writing a raised to the power minus 2 is 1 over a raised to the power 2. So another way of writing 1 over 8 is 8 raised to the power minus 1. This minus becomes 1 over. Then we have 8 raised to the power 1. 8 raised to the power 1 is 8. So our y equals to 1 is correct. Having checked from here, our y equals to 1 this question, I think, in 2013. So we are working with the trends and patterns of these examination bodies. Like I said earlier, these two topics, there is a correlation between them in that the same rule that applies to indices applies to logarithm. So I'm taking them together because I will not take logarithm without you having an understanding of indices. Let me take one more example on this. 1 over 81 raised to the power x minus 2 equals to 27 raised to the power 1 minus x. One all over 81 raised to the power x minus 2 equals to 27 raised to the power 1 minus x. How do we solve this again? Like I said, we have to be able to express numbers in their powers. Just from what I said, we said here concerning numbers with negative powers. A raised to the power minus 2 becomes 1 over a raised to the power 2. This 1 over 81 raised to the power x minus 2 can be written as 81 raised to the power minus 1 and then x minus 2. Another way of writing 1 over 81 raised to the power x minus 2 is 81 raised to the power minus 1 x minus 2 equals to 27 raised to the power bracket open 1 minus x. Then we have 81. Like I said, don't forget, you have to be able to express numbers in their powers. 81 can be written as 3 raised to the power 4. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. So 3 raised to the power 4, brackets, okay, 3 raised to the power 4, brackets open. Now let's solve this bracket first before we move to 81. We can have it as 81 minus 1 times x gives us minus x. Minus 1 times x gives us minus x. Minus 1 times minus 2. Minus times minus gives us plus. 1 times 2 gives us 2. Equals to 27. Then we have our 1 minus x. This can be written this way. Now, 81 can be written as 3 raised to the power 4. We have to be a fast thinker when you are dealing with indices. How do you express this number in powers? Then you open your bracket, minus x plus 2 equals to 27 can be written as 3 raised to the power 3. It's the same thing as 3 raised to the power 3 times 3, 9. 9 times 3, 27. Please, I have seen some people, 3 raised to the power 3, they will say it's 9. No. 3 raised to the power 3 means 3 times 3 times 3, which gives us 27. So 27 becomes 3 raised to the power 3. Then we have in bracket the power 1 minus x. Again, when you have bases separated by this equality sign, simply cancel the equalities, cancel the bases because they are similar bases. Simply cancel these bases, and then you deal with the powers. 4 times minus x gives us minus 4x. 4 times minus x gives us minus 4x. 4 times 2 times plus 2 gives us plus 8 equals to 3 times 1 gives us 3. 3 times minus x gives us minus 3x. Now let's collect like terms as usual again. Minus 3x wants to move across the equality sign. Mind you, you can move this here. It does not always have to be from right to left. You can move from left to right if you so wish. Now, I'm moving from right to left. Minus 3 wants to cross the red C, the equality sign. Minus 4x is already here. Minus 3x crossing the equality sign becomes plus 3x equals to 3 is already waiting here for 8 to come because they are one family. 3 is standing plus 8 here, crosses to the other side and becomes minus 8. So minus 4x plus 3x. Just like saying minus 4 plus 3. Minus 4x plus 3x, I am owing you 4 naira and I have 3 naira. If I give you the 3 naira, that means I'm still owing you 1 naira. So we are left with minus x equals to 3 minus 8. 3 minus 8 gives us minus 5. Minus 5. Now you can see simply this one has a negative sign, this one has a negative sign. Then our x equals to 5. The value of x in this question is equal to 5. In this equation now, the value of x is equal to 5. Minus x equals to minus 5 because they both have negative signs. Minus cancel minus, then we are left with x equals to 5. So in this equation now, the value of x is equal to 5. And this is not difficult, but understanding the rules makes it easier. Understand that when the powers are different, but the bases are the same, and the two numbers are separated or are joined together by a multiplication sign, you are supposed to add the powers and pick one of the bases because the bases are the same. But when it is joined together, when the numbers are joined together by division sign, you pick one base if the bases are the same, and then you subtract the powers. And I did mention that anything raised to power 0 in mathematics, anything raised to power 0 is equal to 1. 1 million raised to power 0 is equal to 1. I also said something about the negative index. For example, 2 raised to power minus 2 is the same thing as 1. This minus becomes 1 over. Then we have our 2 raised to power 2. I hope that's simple enough. That is very simple enough. So, from here, we'll be going to logarithms. From here, we'll be going to logarithms. Like I said, the same rule applies to logarithm. The same rule that applies to indices applies to logarithm. So, it is always better to have an understanding of indices before you can do anything on logarithm. That's why I like teaching them together, because they are the same. Yeah, before I go into logarithm, I have given us the rules. I talked about those rules. Now, let's say we have something like this. We have what we call the fractional index law in indices too. The fractional index law. This is the kind of, in this situation, you have the power to be a fraction. How do you express this? In what other way can we express this 2 raised to power 1 over 2? When it is a half, it is a fraction, rather. This 2 stands for the roots, square roots, and then we have 2 raised to power 1. 2 raised to power half is the same thing as square root of 2. Or if we have 4 raised to power 3 over 2. What we are saying is this denominator of the power, because the power is the fraction, the denominator is what we have here as roots, square roots. Normally, you don't need to put the 2 here because this sign already stands for square roots. So, this sign here, the denominator is 2, which means this, and then we have 4 raised to power 3. This is another way of writing this. What if we have, so it does not always have to be 2 to be the denominator. What if we have 8 raised to power 4 over 3? This is the denominator, this is the numerator. Then we have the cube root, 8 raised to power 4. This is the way it should be written. We did not put 2 here because this sign already stands for square root. But by putting 3 here means 3 is the base, is this denominator, is this sign, 3. Cube root of 8 raised to power 4. So these are other ways of writing this. You will need this when we are working with logarithms. So let's go into logarithm. Don't forget the same rules that apply to indices apply to logarithm. I have said earlier that we don't need to use four-figure table in solving this. Our understanding of indices will help us to solve logarithms. Let's look at this example. Now, okay, let's look at this example before we go. Given that log a base 10 equals to 2, find the value of a. Now, log a base 10. This is the base, and this is the logarithm itself. Log a base 10, that's how we call it. Log a base 10 equals to 2. Find the value of a. Say log a base 10 equals to 2. Find the value of a. Solution. How do we solve this? There's something we do here. Log a base 10. So like I said, I don't need to feed you with so much information. Now let me just give you the logic. Equals to 2. What you do is this. Forget about the logarithm. Forget about the log. Simply say a equals to, this 10 comes here to become the base and 2 becomes the power. I don't need to feed you with information, too much information. You have been fed with too much of that from your primary to your secondary school level. Now, what you need is the logic, the key to passing this, your exams. Now, log a base 10 equals to 2. Find a. A is here. Forget about the log. Let this 10 now, which is a base here, log a base 10, come here to become a base here. Then it raises 2 up. Then a equals to 10 raised to the power 2. A equals to 10 raised to the power 2. You can always write a equals to 10 raised to the power 2, which is 100. 10 times 10 is 100. So the value of a here is 100. The value of a here is 100. Don't forget, the logic is 10, which is a base here, comes to this other side and pushes 2 up. Forget about the logarithm. That's the way we do it actually, but I don't want to give it to get you confused. 10, the logarithm is cancelled. Forget about logarithm. The 10 comes here, becomes the base, and pushes 2 up. That's just the logic. For any examiner, you write this, you understand what you are doing. So you don't need to prove anything to any examiner. You don't have all the time in the world in your exam. You don't have all the time in the world. So, like I said, we are going to be using simplified methodologies while also maintaining conciseness. So, the a equals to 10 raised to the power 2. So the value of a in this question is 100. A is 100. A is 100. Using your calculator or anything, the answer will always be 2. The answer will always be 2. Meaning that if you replace a with 100 here, the answer will be 2. When you use a calculator, you will see that the calculator has been programmed already. The base is already in base 10. It has been programmed such that the base of any logarithm is base 10. Base 10 is a natural base. That's the natural logarithm we have. So when you press, you don't need to press base 10 in your calculator. When you just press log 100, the answer will give you 2. It means the calculator has been programmed to have the base as 10. So that understanding will help us again in another one. Let's say we have log log x base 4, log x base 4 equals to 3. Find x. Log x base 4 equals to 3. Find x. Now, again, don't forget the logic. X equals to this, forget about the logarithm. 4 comes here as the base, and then it pushes 3 up. Therefore, x equals to 4 raised to the power 3. 4 times 4 times 4, which is what? 64. So that is the logic. 4 comes here, pushes 3 up, then 4 becomes the base, the 3 goes up as the power, x stands alone. Forget about the log now. Take the log away, leave the log. Then x equals to 64. That is how simple it is. It is as simple as that.